Yeah, so we'll see about division of two 8-bit numbers. So as you have seen before, multiplication of two 8-bit numbers is nothing but repeated addition process. So division of two 8-bit numbers would be repeated subtraction process, exactly. So we'll take an example and learn this. So we'll have the dividend value as 4, the divisor value as 2, and we'll have another thing, quotient as 0 initially. Now we are comparing the dividend and the divisor value. In order to perform a division, the dividend value should always be greater than the divisor value. So we are checking that using this particular step. So 4 and 2 are compared, and the dividend value is greater than the divisor value in this case, and so you are incrementing the quotient value by 1, and you are subtracting the divisor value from the dividend and storing the difference back into the dividend. So that is 4 minus 2 is equal to 2, which is stored back into the dividend. Now you are again comparing the dividend and the divisor value. In this case, both dividend and the divisor value are the same. So again, quotient is incremented by 1. Before it was 1, so 1 plus 1 would be 2, and dividend and divisor are subtracted, and the result is stored back into the dividend. That is 2, which is dividend, and 2, which is divisor, is subtracted, and the difference is 0, which is stored back into the dividend. Now dividend value and the divisor value are compared. So dividend value is 0 now, divisor value is 2, those two are compared. In this case, dividend is less than divisor, so this doesn't satisfy our criteria for division to be performed, which is dividend should always be greater than divisor. So you are storing, so the quotient value, you are terminating the program, and the quotient value remains as such, and the remainder is nothing but 0, which is the dividend value. So that is how this particular program is going to work, the algorithm program. So we'll see how to code it in 8085. So the first instruction again here is you're clearing the D register. Then this is an indirect way of accessing the address, which is 4150. So the data value at 4150 will be stored into the B register. Now incrementing HL value, which is 4150 to 4151, and getting the data from 4151 to the accumulator. Now you are comparing the accumulator value and the B register value, and if carry exists, that is, this instruction compare B does what it does is it performs the subtraction of A and B, that is A minus B, and accordingly will affect the flags. That is, if A minus B is less than 0, then carry flag would be set. In this case, A is the dividend and B is the divisor, and our criteria for division to be performed is dividend should always be greater than divisor. So if it becomes, in any particular case, if it becomes less than the divisor, then we need to jump to part 2 and store the accumulator value to the desired memory location, and deregister value to also 4153, which is our desired memory location. If not, if the dividend value is greater than the divisor, then you increment the deregister. Deregister will store the quotient in this case, and you subtract B register value from the accumulator and store it back to the accumulator. So accumulator here is dividend and B register here is divisor. So in this case it is 4 minus 2, so that is 2, that is stored back into the accumulator. Now jump to part 1. Now it will loop to part 1 again and compare accumulator and B register. In this case 2 and 2, that is, they are equal values, so carry flag won't be set, rather 0 flag would be set, and we are not checking for 0 flag here. So it will again execute these 3 instructions, and in this particular instruction deregister value becomes 2 now, and for this instruction the accumulator value becomes 0, and again you are looping to part 1. So 0 is less than 2. In this case 0 minus 2 is results in carry flag being set, and so this instruction becomes valid. So you are moving to part 2 and storing the accumulator value, which is 0, that is a quotient, into the address location 4152H, and you are moving the quotient to the accumulator and storing it in a desired memory location 4153H. So taking the same example in the processor and doing a step-by-step execution process, having 4150 as 03 and 4151 as 06, we would find the quotient and a remainder. So in this case you can see a looping process that was going on, and the quotient is being stored, remainder is being stored into the address location, and the quotient as well is being stored to 4153. So our answer here would be, in 4153 it is the quotient, which is 2. Our input was 3 and 6, where 6 is the dividend and 3 is the divisor. So our quotient root should be 3 by 6, that is 6 by 3, that is 2. So 4153 is 2, and we don't have any remainder, so remainder here is 0, 0. So that is about division of two 8-bit numbers.